Hey, hi everyone, welcome back to our daily LeetCode challenge series. So today is day 91 and today we are going to solve LeetCode problem 209 minimum subarray sum. Okay, so this is an easy medium level problem. So let's see the problem first. So we have given an array of positive integer nums and a positive integer target. Return the minimal length of a subarray whose sum is greater than or equal to the target. Okay, so if there is no such subarray, return 0 instead. Understood. So basically we have given a target number and as like array, we have to find a minimum subarray sum whose sum is equal to target or greater than target, right? So nearby greater we can say. If it is 7, we don't have any sum set whose sum is like 7, then we should go with a or 9, whatever nearer. Okay, so in this case we can see like if we sum 2, 3 and 1, we'll get 3, 4, 5, 6, but which is lesser, so we can't consider. But if we take this 2, so 8, which is nearer, so we can consider that value again. If we check some minimum one, then here we are getting 9. If we check here 4 plus 3, 7, so here the size you can say it is 2, and which is minimum and equal to 7, right? So that's why the minimum size we have to return. So we can say here 2 is the answer, right? As in the expansion we can see we are returning 4 and 3, which is size 2, so returning 2. Fine. Similar example 2, we can see target is 4, so we can see like if we give the subarray of single digit or like single number, so we can say size minimum size is 1, subarray size, right? In case of example 3, we have this size, but after adding up all the elements we're still not able to raise the target, right, which is always minimum. So that's why in that case we are returning 0. So as expected it is even. If there is no such subarray exist, then you have to return 0 instead, right? Okay, so in the constraint part we can see target is given, which is greater than 1 or less than 10 to the power 9. Fine. Array length can be varied from 1 to 10 to the power 5, and the value within the array can be ranged from 1 to 10 to the power. That means mostly all are in the positive number, right, and within the integer range. Fine. So in follow you are given figured out ON solution. Try coding another solution of which the time complexity is O of and log n. Fine. Anyways, we will figure this out, follow question later. First we will see how we can approach for the solution. So in my point, like what we can do is I'll go with the 2-point approach first, right? So in this 2-point approach, what we'll do, we'll iterate starting iterator from here, and we'll keep one variable which will have the current sum, which basically going to check if whether it is equal to the target or greater than target. Then we will store in some like variable, right, to track whichever we have got the minimum one, right? So we will first increase our first pointer, then get the sum, then again increase the pointer, get the sum. Similarly, if we found some condition which is equal to or greater than target, then we will pick that size. So size means like first pointer and last pointer difference of the index, we will get the size, right? So in that case we will get the size, we will store it. Then again we'll as we've got the larger one, what we'll do now, we'll iterate the left pointer and right pointer. If it is sum, again then we will increase the right pointer, we'll get the sum. We'll see if the minimum sum that we have stored currently, if it is lesser than this and equal to or greater than this, then we will like change that value. Otherwise again what we'll do, we'll remove like increase our left pointer. If it is the sum is not same, then again we'll do, so vice versa we'll do, and at last we will reach this point. We have got the minimum sum 2, right? Then we'll check the target, and in return we are returning 2, right? Okay, so in order to do that, like what we'll do now, so first we'll take the 2 pointer here. So let's say int left pointer is 0, okay, and right also I'm assigning index at 0. Fine. Now we'll take one answer where we're basically going to store the minimum one. So for now I'll take integer dot max value, okay, as our initials answer. Later on we'll update, and we are going to create one sum variable to store the current sum. Okay, now what we'll do, we'll have to iterate over the given array, right, for each element. So what we'll do, we'll start our right index here, and we'll see if right index would not reach to the length of this one. So now start length we can say. Okay, now what we'll do here, we are going to assign into our current sum. Current sum value is none other than the current value of index, right? Okay, so we'll add into the sum. Now here we will check if our current sum is greater than or equal to target, right? My bad, target. Okay, so if this is satisfying this solution, so what we'll do, we'll assign the answer, and here what we'll check the minimum. So whatever the current value we have, okay, sorry, not abstract, whatever current value we have, we'll check if that is the minimum one or the index that we have currently. We can say right minus left and plus 1, because we have started from 0 index, right? So in order to check the difference, actual difference, I am doing plus 1. Fine. Now after getting this, what we'll do, we'll do the minimization from the current sum, the last index. So last index will be our none other than the left pointer that we have, which is already in the 0th place. Okay, now we have moved our pointer. After moving the pointer, we'll increase this, the left pointer, once, right? And after, if this condition is satisfying, then fine. Otherwise we are just moving out our right pointer, that's all. So this is how it will iterate over each and every value and find the minimum, like size of the sub array. Okay, at last what we'll do, we'll simply here return in the sense, we'll see if our current sum is not equal to the one that we have assigned. Integer dot max value. Okay, if it is not equal, then that means there are some answer that we have got. Okay, but if it is so, then we have to just return 0. That's all we have to do, right? And here what we can do, int here, spelling mistake I did. Okay, so hope it will work. Let us submit and see the test cases. Okay, so we can see like all 3 test cases got accepted and we're getting expected output. Now let's submit and see other test cases as well. Okay, cool. So we can see like all 21 test cases got passed and beats 99%. So anyways, like our solution is optimal one. Okay, so here if I talk about time complexity, so time complexity is big of n because we are iterating over each element once we are visiting, right? Either we are using 2 pointer approach, that is fine, but we are iterating over each elements. So the time complexity is big of n, and space complexity is big of 1 because we are using some constant space, right, by assigning some variable for the pointer and the answer storage, right? So time complexity is big of 1 here. So if you know any other approach than this, you can just comment it down. Okay, so that's all for today. Let's see you on next video. Bye.